Good evening, everyone. Today, I would like to present about vehicle dynamics case study. I would like to introduce myself and my teammates. My name is Puarasu, son of Ramchandran. My metric number 01DAD 22F2024. Second person, Iswaran, son of Sivalingam, metric number 01DAD 23F1104. And third person, Devendran, son of Kunalan, the metric number 01DAD 22F2031. Let me talk about case study introduction. In the automotive industry, aerodynamic is very important because it affects how fast, stable, and fuel efficient a car can be. One of the main factors that influence this is the drag coefficient, which show how much air resistance a car faces when moving. In the study, we compare the several car models such as the Mazda 3 liftback, Subaru WRX, and Ford Ranger Raptor to see their aerodynamic performance. The comparison focuses on the size of each vehicle's length and width, and their drugs confuse valve. From the analysis, we can understand how the car shape and design affect its ability to move smoothly through the air objectives. The second is I would like to talk about objective. The first is to list and compare the basic specification, length and weight of selected vehicle models. The second, to study and compare the drag coefficients of each vehicle model. The third, to understand how the car shape and size affect its aerodynamic performance. The fourth, the last one, to give suggestion on how to improve vehicle design for better aerodynamics in the futures. This is the specification table. First, model of vehicles. The first model is Mazda 3 liftback. The length is 4.49 m. Weight 1.795 m. The second model Subaru WRX. The length is 4.67 m. Width 1.825 m. The last is Ford Ranger Raptor. Length is 5.381. Weight is 2.2 m. That all from me. I will pass to my friend. Thank you.
Good evening everyone, my name is Iswaran son of Sivalingam. Now I want to go explain about calculation vehicle model Mazda 3 liftback. Okay, I want to pick first three columns to explain in this video. Okay, first column, okay, velocity 100. For drag force is we calculate we got 249.741 Newton. Okay, for frontal area is 6.0043 m square, and for air density is 1.225 kilogram meter square, and for drag convenience we got 0.09. For 110 velocity we got drag force 302.186 Newton. For frontal area is got 6.0043 meter square, and for air density we got one also got same as we see at velocity 100. We got for 110 air density we got 1.225 kilogram meter square 3, and for drag convenience also got 0.09, same also as velocity 100. For last one, for velocity under 20 we got drag force 359.827 Newton, And for frontal area we got 6.0043 meters square, also got same. And for air density we got also same, also 1.225. For drag convenience also we got 0.09. Okay, let's we see the different, little bit different for our velocity under 30. We got 422.062 Newton for drag force. And also for frontal area we got 6.0043 meters square. And also we got air density we got 1.225, a little bit same, kilogram meter square 3. And for drag convenience also got 0.09. As we see this table, we at different velocity we got different drag force. And for frontal area all of same until the velocity 200. And also the drag air density and also drag convenience also same numbers that getting with our calculation. So that's all. And now let me see for our calculation for Produa Myvi car. Okay, the velocity of 100 we got drag force 249.7 for 1 Newton. And for frontal area we got 6.39 meter square. And for air density we got 1.225 kilogram meter square meter 3. Drag convenience also we get 0.08. Okay, let's see for the velocity of under 10. We got drag force 302.186 Newton. For frontal area we got 6.39 meter square. Air density we got 1.225 kilogram meter 3. And drag convenience we got 0.08. Okay, let's see for under 20 velocity. We got different, a little bit different as we see for under 10 and 100 velocity. For under 20 velocity we got drag force 359 and 0.827 Newton. For frontal area same also 6.39 meter square. For air density also same 1.225 kilogram meter 3. And for drag convenience also same 0.08. Okay, as we see the velocity in different velocity 100 until 200, the drag force we got different calculation answers. And for frontal area we got same because the area memang same. And for air density also same, drag convenience also same. As you see, the with different velocity we got different drag force in Newton. Okay, let's go to calculation to Raptor Ranger. Okay, for the first velocity under, the drag force is 249.741 Newton. Frontal area 8.88 meter square. Air density 1.225 kilogram meter square. And drag convenience 0.06. And for velocity under 10, we got drag force 302.186 Newton. As frontal area, air density, drag convenience also same for all the velocities until 200. So let me see the drag force only lah. For under 20 velocity we got 359.827 Newton. And for under 30 velocity we got 422.062 Newton. For under 40 we got 489.492 Newton. For under 50 we got 561.917 Newton. And for under 60 we got 639.336. Okay, as we see the same also lah. For the calculation for Raptor Ranger, the different velocity we got different drag force, but the frontal area, air density, drag convenience same for until the velocity 200. Through the graph drag convenience versus velocity. As we see the before the slides, we got calculation for Raptor Ranger, for Produa Myvi, for Mazda 3. Okay, we got see the drag convenience is all same for say all different velocity under to 200 velocity. As we see the graph, we can see the left as I see at the left hand side and the bawah side. The drag convenience 0.00 until 0.10. The velocity 100 to 200. The velocity of 100, we see the 0.0. Okay, let me explain the colors. Okay, for the color blue, this is the drag convenience of Mazda 3 liftback. For color dark blue, okay, drag convenience of Ford Ranger Raptor. At the middle is light purple. The light purple is actually the drag convenience of Subaru Vex. Okay, let me see the graph drag force Newton versus velocity. Okay, as I explained in the before slides, we got see the different drag force for the different velocities. The velocities for under 200, we got different drag force for the three graph. We can see the drag force is increased when the velocity is increased. Okay, for the first graph, we can see first graph, second graph, third graph also same, but the different calculation answer we got is just the different answer, but the increased level is same as we see in the graph.
Hi, I'm Devendran. My matric number is 01DAD22F2031. Now, I would like to talk about result. From the data collected, each vehicle model has different drag coefficient value due to variation in body shapes, size, and design. The Mazda 3 liftback shows a lower drag coefficient compared to the Subaru WRX and Ford Ranger Raptor. This means the Mazda 3 has better aerodynamic performing, allowing it to move more smoothly through the air with less resistance. The Subaru WRX has a moderate drag coefficient because it is designed for both performance and stability. Meanwhile, the Ford Ranger Raptor has the highest drag coefficient among the three due to its large body size and off-road design, which increase air resistance. In conclusion, car shapes and size play an important role in aerodynamic performance. Smaller and more streamlined cars, such as the Mazda 3 liftback, generally achieve better aerodynamics and fuel efficiency compared to large vehicles like pickup truck. Conclusion: based on the result of this study, each vehicle model has different aerodynamic performance depend on its size and design. The Mazda 3 liftback shows the best aerodynamic efficiency because of its compact and smooth body shape. The Subaru WRX performs moderately, balancing between sports performing and stability, while the Ford Ranger Raptor has the highest drag coefficient due to its large body and off-road design. This study shows that a car shape, height, and surface design have a big impact on air resistance. Vehicle with a lower drag coefficient can move more easily, save fuel, and perform better at high speed. Understanding these aerodynamic factors helps engineers design vehicles that are safer, more efficient, and environmentally friendly. Here is the reference. First is Aerodynamics Wikipedia retrieved from. The second one is Drag Coefficient Wikipedia retrieved from. Third one is Mazda 3 Wikipedia retrieved from. Fourth is Subaru WRX Wikipedia retrieved from. The fifth is Ford Ranger Raptor Wikipedia retrieved from. That all from us. Thank you for your attention.